Welcome to the City of Becker's virtual wastewater plant tour with your guide, Chris. Listen.
Okay, so this is the domestic influent wet well. So this is the main collection point for all the wastewater from the City of Becker other than what comes from Liberty Paper. So Liberty Paper, all that waste flow is through a separate line and goes through the industrial wastewater facility. All the other sewer discharge from the businesses and the residents in the City of Becker goes into the domestic collection system and flows into this wet well. So this wet well is fairly deep. So the City of Becker right now has 12 total lift stations. So if you're talking wastewater flow, ideally you would build your city on top of a hill and your wastewater treatment facility would be at the bottom of the hill, because that way all we'd have to have is pipes and gravity would take all the wastewater from where it's being produced to where it gets treated. As we know, most cities aren't built that way. So in order to compensate for that, we have to have lift stations, or pump stations, which are essentially large holes in the ground, cement tubes basically that your wastewater flows into, and then pumps will push that wastewater up and through force mains to a point where they can gravity flow again, and eventually it'll get back to your wastewater facility. So sometimes wastewater can travel miles and miles and miles before it gets to the destination where it's treated. In Becker, our wastewater facility is pretty close to where it's produced, so we don't have too much of that. Let's see, let's go into, so this is the domestic influent wet well. We have 3 pumps in here currently. There is a place for a 4th pump. So as our flows increase, we could add another pump in there. Each of those pumps is rated at 1,480 gallons per minute. So if all 3 pumps were to kick on, we can move a lot of flow really quickly. The wet well itself is 35 feet deep and 15 feet across. So when engineers are designing things, they're trying to not only account for what your flows are now, they try to project what your flows would be 10, 15, 20 years down in the future, and then they'll build these structures based on what that would be in the future, so we don't have to build it over and over again. Once the wastewater comes in, it goes in here, it's pumped, it pumps out of our wet well and goes into the first part of our treatment process, which is the domestic headworks building. The domestic headworks building is where we do things like screening and grit removal. We have kind of to protect our downstream processes. So anything that comes into the wet well that can't be treated by the bacteria in the oxidation ditch that could be harmful to machinery or equipment or just take up space in the treatment process, we try to get that out in the front end. We'll go into that building and we can kind of take a closer look at that. Okay, so the next step in our treatment process is, so everything comes in raw in our wet well, the pumps pump it up into our influent building. The influent building's here basically to kind of protect our downstream processes, try to get things out of the waste stream that the bugs, the bacteria can't treat. This is our influent screen. This is a climber screen. So the wastewater is coming in this channel here. Down below in there is actually a screen at the bottom that the wastewater flows through. And then on top, so you can see where any debris that is coming in would be caught by the screen. We have a rake right there on the screen itself. When the level per the transducer reading gets high enough, so enough debris is on the screen, it tells the rake to turn on. Rake travels down, scrapes the screen, and deposits the material on the other side. So you can see here all the material is scraped off and it drops into the tube down below with an auger. So essentially this material will go to the landfill. It goes in a garbage bin just like you do of your home. The idea of this auger is it's trying to de-water the screening, so it's squeezing water out so that we're only throwing away the material, not the water. So it helps keep the containers within the weight that the garbage truck can actually dump them. So material comes in, it gets screened out, and then the water is squeezed out of it and it's dropped down into a garbage bin. So the second part of our domestic headworks building, so upstairs the screen would be there to remove larger debris, things we don't want in there. We also like to get rid of grit. So grit is kind of defined as inorganic material that the bugs won't treat or break down. If it passes through here, it goes into our oxidation ditch, it'll settle out and just take up space in the treatment process. So we try to remove as much of that as we can to save space in the treatment process. Essentially what we have is outside of this building, there's a large underground tank. So as the wastewater stream flows through the tank, there's a paddle in there that will slow the flow down. So the wastewater comes in, hits the paddle, the stream slows. Anytime you slow wastewater down below a certain speed, solids will want to settle out, including the grit. Those solids settle out into that tank, which is right behind that large wall right there. There's a grit pump here, so it'll take the contents of that tank, it'll pump that material up through this pipe, and it'll go into our grit separator here. So you can see the large blue portion of that machine. Water comes up through. As it goes through, it spins. When it spins, the idea is it throws the water off, and the grit passes through and drops into this conveyor, and then is removed and into a dumpster. So you can see in this one here is kind of some of that material. So what we're talking about with the grit a lot of times is things like coffee grounds, sand, eggshells, cigarette butts, different things that we won't break down the treatment process and again just take up space. Process, we went from inflow and wet well, the pumps pumped it up to our headworks building, so we did our preliminary treatment, we removed our grit and all our screening material. Now the wastewater flow will pass from that building down into this tank. We refer to this tank as our anaerobic selector basin. So selector is the term you would say is it's choosing something, you're selecting something. The easy way would say is this is how we select which oxidation ditch we're sending flow to for the next step in the treatment process. But actually what the selector would refer to is in this tank we're trying to create an anaerobic environment. So in our oxidation ditches we're aerobic, so we have bugs that like oxygen. In this tank we're creating an anaerobic environment, so an environment that has little or no oxygen. And so we create an environment for a different kind of bug that does a better job of removing phosphorus from our wastewater supply. So in this tank, we're actually trying to select a certain environment to encourage the growth of a certain type of bug, which helps us do removal of some of the nutrients that were required to remove from the wastewater without doing chemical addition. So we can use bacteria instead of spending money on chemicals. So that's why we refer to it as an anaerobic selector basin. So, and then when I do the wastewater tours for like high school students, a lot of times the first part of it I ask them a question. I ask them, as the idea of being future taxpayers, I like to try to get their minds wrapped around the idea of, well, you pay taxes for a reason. So why does the city need all this money it takes from me? Well, there's a lot of functions the city provides, including providing you with drinking water and treating the wastewater that you produce. I give them an idea of how much we spend on our domestic wastewater facility each year for treatment operations. And then I ask them, well, why do we do this? Like, why can't we just have a pipe out in our backyard and just everything that we make just kind of trickles out in the backyard and, nature will take care of it? Well, short answer is nature would take care of it eventually, but it would be along with some really nasty things and potential where you have people being in close contact with materials that may carry diseases and things. So I tell them, if you think back, the Roman Empire was kind of the first ones to really think about this. They started off with having open air sewers in their streets with the idea of carrying waste away from living spaces, away from those living spaces, and the idea that they realized that a lot of disease was coming from the waste that people produce. So if we could get that away from the people, we'd decrease our exposure to disease. We've taken that a step further now in our wastewater treatment process, and we've built these big facilities that, one, help us take waste that's produced by businesses or residential properties in the city. We can carry them safely underground, get them back to our facility, and then we can use the bacteria, similar to like what would happen in a pond or in a river. If you discharge raw wastewater into a river, there's bacteria there, and they would treat that wastewater and break it down. What we do here is mimicking that, but we do it in a much smaller footprint, and we do it way more efficiently so that we can protect those receiving streams. So the things like the Mississippi River won't have large sludge mats floating on it because we're discharging raw wastewater into the Mississippi River. So that's some of the reason why we have wastewater treatment plants. So the wastewater treatment facility has an NPDES permit. That permit is governed, issued by the Minnesota Pollution Control Agency, or MPCA. One of our requirements in that permit is that we have to be able to treat wastewater even if there is like a power outage. So if for some reason we weren't getting power from the power company, we still have to continue to treat the wastewater that comes to the facility. So that's why we have both a generator for the domestic wastewater plant, and then we have a generator for the industrial wastewater plant. So 2 large generators on site, so this plant can continue to treat wastewater even if we don't have power coming from the outside. Headworks building, we did our preliminary treatment, went into our anaerobic selector basin, so we mixed our raw influent in with some of our return activated sludge, or RAS. So basically bugs that we already have in the system are being mixed in with the food that is essentially the influent. It leaves the anaerobic selector basin and moves over into our oxidation ditches. We have 2 domestic oxidation ditches currently. If you see off in the expanse there, we do have room for expansion in the future. Each one of these tanks can hold 650,000 gallons of liquid, water, wastewater, whatever you want to say. So currently we're at about 1/3 of the capacity of our wastewater facility. So we can do the treatment with just one of the ditches. So we have one online for half the year, then we switch and have the other one online for half the year. Reason for that is we take it down, we can do any checks that we need to do, any maintenance on the aerators themselves. The idea in these ditches is that we're continually to rotate the ditch, stir the ditch, mix the ditch. That's the job of the carousel aerator. So on top you can see the electric motor and then the gearbox for that. And then there's a shaft that goes, and down below we have the aerator itself. I don't know, maybe like a big boat motor if you want to equate it to that. That essentially is spinning, and we're continuing to move around. And the liquid that we have in the tank in the wastewater industry is called mixed liquor. So mixed liquor suspended solids, or MLSS. It's essentially the bacteria, the bugs that do our treatment. So some examples of that could be like algae, nematodes, rotifers, ciliates, flagellates, all those kind of good little swimmers. They're in the ditch. We mix them with the food that is the influent, so the waste that's produced by our residents and businesses. And the aerator continues to mix it. In the wastewater world, 2 milligrams per liter of dissolved oxygen in this ditch provides an aerobic environment, which is the kind of bugs that we want to do this treatment. If we provide them that oxygen, we keep them happy, they will treat the wastewater very well. So these are our aerobic oxidation ditches. So next step of the process, the wastewater, it's being treated by the bugs in the oxidation ditches. After it's treated, the next step goes to the clarifiers. So we have 2 domestic clarifiers here. A clarifier, in simple terms, is just a settling tank. So the wastewater goes from being mixed and stirred in the oxidation ditch to being slowed down where our bugs and material can settle out, and the clear water that they've produced through their treatment process can be taken off of the top and go on to the next part of the process. The bugs and things that settle out, we do need to remove them from those tanks, and we will remove them, and we call that, the bugs that we remove, 2 different things. It either is RAS or it can be WAS. They're the same thing, if it's RAS, it's return activated sludge, so we're returning the bugs into the system to do more treatment. If it's WAS, they're waste activated sludge, and we're taking bugs out of the system. So as wastewater operators, one of the biggest things we can do to control our process is to keep the right aged bugs in our treatment process and in the right amount. So bugs that are really young and bugs that are really old do not treat wastewater as well as bugs that are kind of middle-aged, let's say. So what we do is we do process control testing. We do check our concentration of our mixed liquor. If that concentration gets too high, we will want to increase our wasting to get more of the bugs out of the system. If our mixed liquor is too low, then we want to reduce our wasting and keep more bugs in the system. These pumps right here are moving liquid out of the clarifiers, so the settling tanks. They're taking the mixed liquor, the bugs, out of those tanks, and they're either going to push them through the return line and move them back in the system to do more treatment, or the dark brown line over here to my right is our wasting line. So same pumps moving it. There's a blue wasting valve on top. It's controlled by our SCADA system. The SCADA system tells it when to open and close based on the amount of wasting we set in there. It'll, on command, open up, and then it'll push, these pumps will push those bugs that we're taking out of the clarifiers out to the waste tank where they can be processed by our rotary presses. Part of our MPDS permit, we have effluent limits that we have to maintain. One of those limits is for phosphorus. So phosphorus is a nutrient. The more phosphorus you have in a surface water, the more likelihood that you will have that there will be overgrowth of plant life in that surface water. So PCA regulates how much phosphorus wastewater facilities are allowed to discharge. We currently have a limit of 1 milligram per liter, and that's a rolling average. So we take how much we discharge each month, we total it up for the 12-month period, the 11 months before in that month, and we have to stay below a certain loading number, and we have to stay below a concentration of 1. One way that we can reduce, we can use our bacteria and remove it biologically. So if we go back to earlier, we're in our anaerobic selector tank. Okay? Anaerobic bacteria can remove some phosphorus from wastewater. It's a very touchy process, so unless you have it just right, a lot of times they're not going to remove as much phosphorus as you need to per your permit. Another way to remove phosphorus from wastewater is by chemical addition. So the two main chemicals that can be used for phosphorus removal are either alum or ferric chloride. We currently use alum here at the wastewater facility. It's a little bit cleaner chemical. They work about as well, so there's not a huge difference between them. So we have alum pumps that feed alum continuously into the process, and essentially what the alum does is it helps grab that phosphorus so that when we waste material out of the system, we're wasting that phosphorus out of the system rather than it passing along and being discharged into the Elk River. Okay, so these are our domestic side effluent, the final clarifiers. These clarifiers are center feed, rim discharge, so the material that's coming out of the oxidation ditches comes into the clarifiers through a pipe in the center. Material comes up and then works its way out from the center to the edges of the clarifier. If you look on top right now, you can see that there is some material, so there's some floating matter that you have in a clarifier. This here is our skimming arm, so this rotates around, it gathers some of that floating material, and then the squeegee at the end, when it comes over here to the scum beach, will actually push that material up and in, goes into that little wet well between, and then that gets pumped out to our waste tank. So we try to remove that, keep it from being discharged with our effluent. Clarifiers are essentially settling tanks. Both of these clarifiers have 55-foot diameters, and they're approximately 18 feet deep, so they're pretty big tanks. All we're trying to do here is we're taking the mixed liquor from our oxidation ditches, and we're going to settle that out. We're going to try to settle the bugs out, remove that treated clear water that they made, and we'll send that treated water on to our filter building. The bugs themselves will use our RAS pumps that we just talked about, and we'll push those bugs back into the head of the facility, mix it with raw influent, and we'll start the treatment process over again. We settled our mixed liquor, our bugs out. We have clear water now leaving that we're going to discharge into our receiving stream. This is our filter building. So as a tertiary step in the treatment process, or kind of a cleanup step or a third step in the process, we are running that clear water from our clarifiers through these filter media. So the water comes out of the clarifier, comes into the filter here. You can see right here is where it actually is coming into the filter. So it enters, it goes over the sidewall there, it goes into the filter itself, and then you can see we have several of the discs that have a cloth media on the outside of them. What happens is that wastewater is going to flow through that cloth media down to that center tube and then flow out and go on to our UV treatment. The idea is here, this is just kind of further cleaning our discharge from our clarifiers, helps to further remove phosphorus, total suspended solids, cleans up our effluent so we can better meet our, not just meet, but exceed what is our effluent discharge limits. So it's an additional step in our treatment process. not all facilities have this. We do. So then you can look here. You can see what one looks like when it's not full of water. And then you notice we do have some bug lights in here. So we have little flies that are kind of particular to wastewater treatment. In our alum building, we actually feed a chemical called Strike that helps to kill the bugs and prevent them from proliferating. And we've also had the bug lights because if we don't do that, you can see on the walls where we have some of the cobwebs and things, these bugs will just keep producing, and you wouldn't be able to walk in here without swallowing them all full of bugs. So we do some processes to try to keep those down, more for our own benefit as operators, not so much because it makes a difference with our treatment process. So, okay, this is the UV disinfection building. So this is kind of the last step in the process on the domestic side before we mix our effluent from the domestic side with our effluent from the industrial side. Then it becomes our combined effluent and we discharge it into the Elk River. The purpose of the UV is if you're a facility that discharges within a certain distance of a downstream user of that same water body, then you have to do disinfection of your discharge just to ensure that somebody that's using it for drinking water further down, you're not making it not usable for their drinking water. So the UV system, the way I've always understood it is it uses UV radiation. So down here we have banks of light bulbs. As the water flows by those light bulbs, they're creating UV rays. That UV radiation is essentially, it doesn't kill the bacteria, but it causes them not to be able to reproduce. So we basically take whatever's there and we make sure they can't make more bacteria and then discharge them out. This is a Trojan system. It's pretty common in the wastewater industry. You can also do chemical addition to disinfect and then do a different chemical to dechlorinate or remove that disinfection material. That's a much more involved process, a lot more chemicals. If you can do UV radiation, it's really the safest, easiest way to go. We're very happy that we have that here in Becker. All right, so as part of our NPDES permit, we're required to take samples from certain sampling points. Most facilities, you have two sampling points, where the wastewater comes in and where your effluent leaves. City of Becker is a little different because we have the domestic treatment plant and the industrial treatment plant on the same campus. We have two influent points, so domestic influent, industrial influent. We have two effluent points, domestic effluent, industrial effluent, and then we have a combined discharge. So we are required to take composite samples from all 5 of those points. So there's 2 types of sampling: grab sampling, where you just take one quick sample and then you would test it. There's also composite sampling. So this is a composite sampler. We have a little pump on top right here. It is connected to our flow meters, and therefore it takes that flow meter reading and it will take a sample per so many 1,000 gallons. And the idea of a composite sample is then it gives the MPCA, our regulating body, an idea of what our facility does in that composite period. So for us, it's a 24-hour composite. If you just took one grab, you could take a grab at one point and you might have really low phosphorus, but 3 hours later you might have a much higher number. This composite sample allows them to kind of see what the average is for your facility over that 24-hour period. We're required to keep samples at 4 degrees C. So we have thermometers in all of our composite samplers. We check those daily. If anything is off from that, then we'd have to either address the thermometer and replace it, or we'd have to repair the refrigerator for the sampler itself. Did our UV treatment, and now our flow is going to move on into, this is our combined aeration basin, essentially. So as part of our treatment process, we have to maintain a certain level of dissolved oxygen in the effluent that we send to the river. So we're not taxing the river, we're not causing it to be detrimental to the species that live in the river. So we have a meter at the end that reads what our dissolved oxygen is in our effluent flow. And then we have these aerators, which I always call them big boat motors, that go down, and if our DO level is getting below what we need to have in there, they will turn on and then they will aerate the combined tank, and so that when it goes out, we're meeting our effluent DO limit. Currently, our domestic effluent is coming through this tank here. Our industrial effluent is coming from our clarifiers through the industrial line to this 90, flows through the pipe here, and then The domestic industrial come together here. They pass through that channel. This is our combined effluent sampler, where we take a sample of our combined effluent for our permit requirements. And then it'll actually, as it leaves this channel, it goes underground and out and into our discharge point into the Elk River.
And that concludes the Becker Virtual Wastewater Plant Tour.